Hello everybody. Right, okay, so now as part of the Link series we're going to look at how to set up all of your outputs. Okay, so I've got a whole list down here in front of me exactly what we're going to set up, but I also have all the documentation in front of me as well going through there. So what we'll do is we'll start going through the top, so looking at things like the injectors and so on and so forth. So going to our fuel setup, we've got fuel main. Now this is obviously done as part of the engine setup, so I'm not going to go too much into this obviously there. But obviously we're going to go into our injector setup from there, and this is where we're going to add all our information, which again was going into there. And obviously injector outputs are preset. So in other words, when you look at the actual wiring, you have dedicated pins for all the injectors and the coils. Okay, so you don't need to physically set them up as going through there. Just make sure that all of your information of your injectors is correct, and that you've got everything else set up as well. Okay, and so that's going to be that. And again, coils, pretty much exactly the same thing. You're going to go into your ignition table here. In terms of the actual physical outputs, they are dedicated pins on the ECU. So you just need to make sure that everything is set up correctly. So in our case, we've got, you know, coil over plug because it's a 3UZ, and we've got direct spark edges falling. And again, if you guys want, when you're going through any of this particular stuff over here, you'll see that there's a help browser just to the right of this. I'm going to make this a bit bigger so you can see it a bit better. But everything that you click on here, there is a help section to help you understand exactly what you're doing over there. Okay, so for example, let's just take maximum advance. Okay, so as soon as I click on that, there it pops up over there. So again, it explains exactly what it does. So it says specifies the maximum ignition angle advance that will ever be applied to the engine. All right. So what they mean by that is you've got your main ignition table, but then you have lots of additional ignition tables. Things like based on coolant temperature, things based on intake air temperature, etc., etc. So what they're basically saying is you could have, let's say, 25 degrees on your base ignition table, but you've got a bunch of these add-on tables. Now, if those add-on tables had to take it to, say, 75 degrees for some weird reason, this would effectively stop that. So in other words, you want the value you want in here is literally the most ignition timing you would ever want to put on the engine altogether. Okay, so that's basically what this function does over here. All right. Other things in terms of your ignition, obviously you've got your ignition test, so you can actually test all the coil outputs, which is really nice. And then, as I was saying here, you've got ignition corrections. These are the things I'm talking about here. So you've got coolant temp, you've got intake air temperature, you've got dual ignition tables, etc., etc. You can do individual cylinder ignition trims. So if you want to actually just, do each individual cylinder, if you want to trim it for a particular reason, there you go. So there's all these little additional tables that can add on or subtract from your main table over there. Okay, looking at this is now your dwell control table. So effectively, this is information you're going to need to get from your coil supplier, or find it on the internet, or etc., etc. If it's a very popular coil, there's going to be loads of information about it. But that's what you're putting in this particular table over here, is your ignition dwell control settings. Okay, and then obviously you can see here, this is our ignition table. Now this is our main table that gets tuning from there. All right. Okay, so that's the injectors and coils done. It's very easy to go through. You're kind of just setting up what they are, because again, they are dedicated pins on the ECU. You can't really use them with anything else. But I mean, if you've got an 8-cylinder and you've got 8 injector outputs, they're all going to be used up from there. Okay, so what we're going to do now is I'm just going to move on to the VVTI. Okay, simply because we're going to use 2 outputs for that. So if we go back to our actual thingy, so you see auxiliary 1 and auxiliary 2, those are our oil control valves for the VVTI. Okay, so because it's VVTI related, you're just going to go straight into VVTI control setup over here. You're going to go to inlet bank 1, and you're going to go to effectively, where is it now? There you go, pressure solenoid. So that's the oil control valve, and we've got that set to auxiliary 1 because this is bank 1, okay, or left bank. And then again, exactly the same one here for bank 2. We've got auxiliary 2. So as you see there, auxiliary 1 is oil control valve left bank, auxiliary 2 oil control valve right bank. Okay, and obviously the ECU is grounding it out, hence the negative sign there, because the ECU is grinding it out. It's getting supply 12 volts from an external source. Okay, so moving on from that, we're going to go in and we're going to look at our auxiliary 3. Now this is ACIS, or Toyota's Acoustic Control Induction System. So this is effectively the variable intake runner length. I do have a video on exactly how it works. I actually show you on an inlet manifold what all the components are and what it does. Okay, so for our particular case over here, what we're going to want to do is we've got analog voltage, so auxiliary 3. So we're going to go to our auxiliary outputs. Now, there's actually a few ways of doing this, okay, and I'm going to show you two ways because we're going to use one of them for our oil light over there. But you'll see here, I've got it as a general purpose output, okay. Now then, for the actual ACSI, if you look at the Toyota documentation, the valve sits in an open position, that's at rest state. So effectively you want the valve to be on to close the valves as long as TPS is below 60% and the RPM is below 4,700. Okay, so it's just that top section over there when it actually turns off and opens those valves over there. So going through here now, we've given it a name, so you can press enter and you can call it whatever you want because it's a general purpose output. Give it a name so you understand exactly what it is and it appears in the corner. It's nice and easy to access. So again, we're using auxiliary 3 because that's our next one over there. You can test it to make sure everything is working, and again the active state is low because we're grounding it out through the ECU and we're supplying 12 volts from elsewhere. Okay, so going over to the switch logic now, what we're going to want to do, okay, is we're going to want to make sure that condition 1 and 2 are met. Alright, so remember I said it's got to be TPS below 60% and the RPM is below 4,700. That is when that particular output needs to be on. Okay, so if you go condition 1 or 2, it'll only one of those conditions have to be met in order for it to actually work. If you go condition 1 and 2, then both of those conditions have to be met. Okay. You can also put a on and an off delay. So if you don't want it to keep turning on and off because you're hovering around that particular section over there, you can give it a few seconds of delay. And again, as per usual, help browsers right to the right here and explains to you exactly how it is. Okay, so this effectively here, as it says, is basically hysteresis. So in other words, if the RPM goes above 4,700, briefly drops to like 4,690, and then comes back on again, and it does that within, say, 1 or 2 seconds, you can then put that on and off delay to maybe say 2 or 3 or 4 seconds. So in other words, it would have to go out of those bounds for that particular amount of time before it turned off. Okay, so that's something, again, you decide with your tuner of exactly how you want to run it. Bearing in mind in this particular case it is a vacuum solenoid valve, so there is going to be a bit of time between when the valve actually actuates and the actual valves open or close. Okay, so that'll be something ideally you want to set up on the engine when it's running. Alright, so going down to our first condition or switch parameter 1, as we discussed, it's going to be TPS. Now we're going to use TPS main, probably use TPS secondary, but TPS main is going to be the best one, and we want that to be equal to or less than or equal to 60%. Okay, so again, you can choose from a whole bunch of stuff. You can either say, greater than, less than, equal to, blah blah blah, etc., etc. Okay, so in our case, we want it to be less than or equal to 60%. Then that actual output is going to turn on. Okay. Our switch parameter 2, because remember we told the ECU we want 2 conditions to be met in order for this output to come on. So switch parameter 2 is now going to be engine speed. Okay, so again, you can pick from a multitude of things that you want over there. We want engine speed or RPM. Same scenario, we want the condition to be less than or equal to, and in our case, we want it to be 4,700 RPM. Okay, you do have an option for a third condition if you want as well, and that depends on your situation exactly what you want to do, but that's exactly what we want. We want condition 1 and 2 to be met, and if we scroll down here now, you'll see there that ACSI is active because obviously that is the conditions are being met. TPS is below 60% and engine speed is below 4,700 RPM. Once these 2 conditions are met, so if you're at 70% throttle, 5,000 RPM, that little green indicator will go from active to inactive. Alright, so that's how that works over there. So that's one way of doing it. I'm going to show you how to do the oil light, which is going to show you how to do it the other way. So let's have a look and see what's next on our list. So we've got auxiliary 3. We've got auxiliary 4, which is our ACSI relay. So on Link, the safety feature they built in for drive-by-wire is effectively the ECU controls a relay which supplies power to this one over here, auxiliary, 14 pin 5, auxiliary power for 9 and 10, and you'll see auxiliary 9 and 10 are our drive-by-wire positive and negative controls. Okay, so what you need to do now is you need to go into your electronic throttle. You need to go to your e-throttle setup. Okay, then you're going to have there, and you're going to have E throttle relay 1, because obviously you had the option for 2 relays. But in our case now, ETCS relay is going to be auxiliary 4. So we're going to go over to here. We're going to have auxiliary 4. We're going to control that. Okay, so it's not a PWM output. The active state is low. Yes, so we're grinding out the relay from there. We can obviously test it if we want to as well. And that's where we're going to go. So again, we're going to go through the whole drive-by-wire setup, which is different. This is just putting the outputs on. So it's just to know that that's what you need to do in order for the ETCS system to work, or electronic throttle control system to work. Okay. Right, so moving on to our next one, which we've got auxiliary 4. Let's go to auxiliary 5. Okay, so auxiliary 5 is oil light, which is the one I wanted to go to next. So in this particular case, the customer's got a oil pressure sensor, and we're no longer using the oil pressure switch. In our case, the customer's using this on an IS300, and we have our MPX converter device, which is going to make his dash work, and obviously we want an oil light for the dash. Now then, we could simply just use a general purpose output. Again, we can set one condition: oil pressure is below a certain value. Boom, it goes on. Okay, but you do have a nice feature where you can effectively cause the light to come on at various different conditions. Okay, so this is what we call our general purpose PWM output. So it's a pulse width modulated output. Now with the pulse width modulated output, you can also have it as an on and off, effectively by going to the table and making the value 0 or 100. Okay, so just to briefly show you here, I can make it 0 to be off, I can make it 100 to be on. So 100 is on all the time, 0 is completely off, and it does again stipulate here in the help section that 100 is completely on, 0 is completely off. Okay, so there are particular ones where you want to run a PWM output, maybe things like boost solenoids, maybe things like idle control, etc., etc. But in this case here, we just want something that's going to turn on and off. Now you're asking, why are we using this for an oil light? It should be a very, very simple circuit. It should just be literally coming on when the pressure drops below a certain value. The reason I like to use this particular way of doing an oil light is to give you a much better warning as to exactly what's going on. Okay, so in this case, we don't have a aftermarket dash where you can have like all of this sort of information in front of him. So what I want to do is I want to make sure that the oil light comes on at a better time, if that makes sense. So in other words, when you're sitting at idle, the UZs have very low oil pressure. So you'd have to set that value, if you just used a general purpose output, to an incredibly low value. The oil light would come on every time you're idling when the oil's hot. Now, with this one over here, basically what we can do, okay, is we can use this table to cause our oil light to come on whenever we want. So basically you'll see here that I've set the table up to be oil pressure versus RPM. So to give you an example, if you're at 6,000, 7,000 RPM and your oil pressure is 0.3 bar, okay, or whatever the low value is when it is at idle, you're way past damaging your engine. So effectively what we're going to do now is this table is almost completely blank, but what the customer is going to do when he actually gets it up and running, once the oil is up to temperature, so you've got the engine up to running temperature, what you can basically do is you can rev the engine and you can check the values and you can see exactly what the oil pressure should be on a good healthy engine, and you can then plot that across basically from 0 to 7,000 RPM. And what you can effectively do is, let's say for instance at 2,000 RPM you have 60 kPa of oil pressure, okay, nice warm engine. Then what you can basically do is you can tell it from 40 kPa and below, the light should come on. So what we're trying to do is effectively, when you've got the engine at 7,000 RPM, your oil pressure is very high. If you could have the light come on when the oil pressure drops, say 20 kPa below where it normally is, you might be able to save that engine, because the oil light's going to come on way sooner than it would on a normal old-fashioned oil pressure switch. So that's why I like to use this table, because you can have that oil light come on as a warning way before a normal oil pressure switch would, and that you could then save an engine. Okay, so sounds silly, but that's the reason that I do it. It's effectively so you can have that information to hand right away. And again, incredibly useful if you're not using a dash where you're actually monitoring the oil pressure itself. And in most of the cases, if you're racing around or whatever, you're not got your eyes focused on the dash. Having a little red light flash in the corner of your eye is going to be much more beneficial. And if you can have that come on, if you're sitting at, let's say, 5,500 RPM, and your oil pressure is usually standing at sort of, let's say, 100 kPa, or I'm just throwing figures out here, 100 kPa. If you set your light to come on at 80 kPa, if that thing dropped to 80 kPa, boom, you know that there's something wrong. The oil pressure is working its way down. You have a chance to switch off the engine and possibly save it. Whereas if you let that oil pressure go down to, 0.3 kPa or whatever it is, when you're sitting at idle, the damage is already done. You've lost oil pressure completely. So again, but physically setting it up, again, nice and easy. You're going to go into there, your label, you're going to call it what you want to call it. In our case, we're going to call it oil light. We're using auxiliary 5 as an output. The active state is low, so again, with oil lights, that's the usual setup. It goes to ground. Frequency, just constant, because again, we're just using it for an on-off switch rather than an actual sort of proper controlled PWM. Frequency doesn't really matter as well, because again, we're just using it as an on or off, so we're going to either be 100 or 0. And then effectively, this is where it gets a little bit weird, because in order for it to work, we basically want the switch to be on all the time. Okay, so what you can basically do is just pick a particular setup and just make it so that it's going to be on all the time. So in other words, you can have your switch parameter being oil pressure. You can have your switch condition being, let's say, greater than, so I had that there, and then you can say 0. There you go. So as long as the oil pressure is above 0, it's going to be on. Okay, so that means this is going to be permanently on. And again, it doesn't have to be this one in particular. You could literally say if battery voltage is above 1 volt. Okay, it doesn't really matter what you put in there. This is obviously more if you were going to use a proper PWM table that required PWM, and you're going to have varying states through the table, etc. And you only want it to work at a particular time. Then you can go from there. Okay, so which brings me on to the fact of, if you look at our ACSI output, you could do that with this. All right. Now, the reasons you may want to do this, you may find that the way I've set it up as a GP output is absolutely adequate and it's fine. You can do dyno runs and you can see exactly, where it is. But your tuner may want to have a little bit more control. He may want to be able to activate it at certain times or just play with it. Then he can switch it over to a PWM output, and then he can use his table. He can put load against engine speed, and effectively then he can turn it on and off as he wants to. And because it's a vacuum solenoid valve, I suppose you could even open it halfway if you wanted to. You could have a play around and see what works best. Okay, so that's another way of doing that. So again, many ways to skin a cat. You can do it very nice and basically like that, or you can be a little more complicated and do it like that, depending on your setup, depending what you want to achieve. Okay. So moving on to our next one now, we've done auxiliary 5. Yep. Auxiliary 6 is our fuel pump. Okay, so this is the relay that controls the fuel pump. So again, really nice and easy. You'll see on auxiliary outputs here, we've got here fuel pump control. And all we're going to do is we're going to go pick there. That's a standard one. We're not going to have anything funny there. So the fuel pump relay output is, let's make sure I've got the right one again. Yeah, auxiliary 6. So we're going to go to auxiliary 6. Okay. So again, it's a relay we're triggering. We're triggering it by grounding it out. So again, its active state is low. And then here you can set your prime time. So this basically means once you turn the ignition on, that's how long the fuel pump relay will kick on. Here's for 3 seconds. So as soon as you put the key on, it'll prime for 3 seconds, then turn off, and then obviously turn on again when the ECU commands it, when the engine's actually rotating. Okay, so again, Control S, save that in. Nice and easy. All right, so we're going to go to auxiliary 7. Again, nice and easy. This is our tacho signal output. Right, so again, we're going to choose from down here, and luckily, there it is. We've got a predetermined output for tacho. So we're going to go here. We're going to put it on there, so you see auxiliary 7. So you'll notice as we start filling these up, it gives them their names. So you see I've called that general purpose ACIS, I've called the other output oil light, and it puts the label here so you know exactly what you have and haven't done yet. Okay, so we'll go to auxiliary 7. Again, active state is low. And what we can do here, so this is your multiplier. Okay, so basically this is how you're going to correct the signal for your particular vehicle. So obviously you've got 4 cylinders, you've got 6 cylinders, you've got 8 cylinders. Obviously this ECU doesn't know exactly what's going to be plugged into it. So effectively what you can do is you can use that multiplier to get it correct. So you have to hold the engine at say 1000 RPM, keep changing the multiplier until your dash matches that exact setup over there. Okay, and then This one over here, key on sweep. Some people like it. It's effectively when you turn the ignition on, the actual RPM needle goes from, from 0 to full, then back to 0 again, and then you can tell it exactly how far you want to go. So let's say you've got a dash with a 6,500, complete limit on it there. You can set it to 6.5. If you've got one with 7,000 RPM, boom, there you go. And then you can set the time, how long it takes to go through the sweep. Okay, so those are sort of little nifty things you can do with the tacho signal. All right, so that's all done. So now we're going to go to auxiliary 8. Now, W, that's a Toyota term. That's basically check engine light. Okay, so again, we're lucky it's right here under auxiliary outputs. We have a predetermined thing for check engine light. And in our case, again, yeah, it's auxiliary 8. The active state is going low, so the ECU is going to ground it out. Okay, and then you can set exactly when it comes on. So in other words, when your engine is running, you can tell it to come on when there's fault codes and basically stay on as solid like it would in a normal car, or you can tell it just to flash the fault codes as they come about when the engine is running. Okay, I normally just leave it to on because it's how standard vehicle works, and then obviously you can then read the codes either by your laptop or the software. Okay, or in this particular case, we've actually got an OBD2 attached to the harness so that the customer can plug that in and do all of that stuff. Okay, and then obviously we got the option of the key on with no faults. So in a standard car, when you turn the ignition on, the check engine light comes on. So that's basically effectively what we've got there. So we've just left it to on, so we know as soon as the ignition turns on, the check engine light's going to come on. It's like a nice easy way of telling that the actual ECU is like alive and active as well. So again, I leave that like that. Right, so that's check engine light. So that's our auxiliary 8. And I think that's about it in terms of outputs. Dun, 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 dun. Let's double check through here. I think that's pretty much it. Now the only thing we've got left is auxiliary 9 and 10, and that's to do with our drive-by-wire. So let's just go through there to electronic throttle, E-throttle setup. Okay, and we're in setup mode. Okay, so the PWM output is obviously for the drive-by-wire throttle. So when you click on it, in our case, we're using auxiliary 9 and 10. So again, we just set that up from there. Okay, and that's obviously then going to tell the ECU that auxiliary 9 and 10 is actually active, what the outputs we're using for the drive-by-wire throttle. Again, I'm not going to go into too much detail. I'm going to do a separate video on the actual drive-by-wire throttle itself. But yeah, so that's exactly how that works from there. So again, really nice and simple video. Hopefully it's helped you guys. Again, importance on documentation. If you don't have something like this to know exactly where everything is connected, you're going to have a bad time. But yeah, really nice and simple. Again, we're not doing anything particularly complicated here, but I thought it's just a nice little video to give you guys the opportunity to set things up. I've tried to go through the different ways that we do it from there. There is a lot more that you can do, obviously. We're probably barely scratching the surface of what we can do. But again, this is only just setting up the inputs and outputs. So I'm going to leave it here now. I think we've been 23 minutes already. Okay, and I'm going to move on to the next subjects, which is going to be the rest of the setup and so on from there. All right, but again, guys, thanks for watching. If you have any questions, do feel free to ask away. Hopefully it hasn't been too long and you've actually stayed till the end. But yeah, we'll speak to you and see you again soon. Bye-bye.